Okay, so we're going to talk about section 10.2, sum and difference identities. I've got the cosine and sine ones up on the screen for us. So remember, for cosine, the functions match, but the sign, positive, negative in between, is opposite. And then for the sine identity, the functions are different, but the sign, SIGN, in the middle matches. Okay, so there are two identities that we're going to use. And then how do we use these? So let's say we want to find an exact value for cosine of 75. Okay, that's not one that's on our unit circle. And we could use our calculator, but that's not going to be exact. That's going to be a decimal approximation. So let's see if we can rewrite it using one of our identities. So we could write cosine 75 as cosine 30 plus 45. Okay, 30 plus 45 is 75, and we know the values for 30 and 45. So we're using our cosine addition identity, which is the first one. So that's going to be the same as cosine 30, cosine 45. The sign reverses, and then we've got sine 30, sine 45. Okay, now we're looking at values that we know off of our unit circle. So we know that cosine of 30 is square root of 3 over 2. And cosine of 45 is square root of 2 over 2. And we know that sine 30 is 1/2. And we know that sine 45 is also square root of 2 over 2. Okay, so what we get in the first term, we get square root of 3 times square root of 2 is square root of 6 over 4. Remember, we multiply numerator and denominator. And the second term is going to be 1 times square root of 2 over 4. We've got a common denominator, so we can put these together. And remember, we can't put square roots together unless they're identical, so that's as simplified as we're going to get, and that's our exact answer. Okay, so that's one example. You can use it to find values that we wouldn't otherwise know. We can also use this to prove some of the identities that we had seen looking at a different way. So let's try to prove an identity using these. Okay. There we go. All right, so let's say that we have, we want to prove that sine of 90 minus theta is equal to cosine theta. Okay, that was one of our identities that we saw a couple sections ago. So we looked at it on a triangle and kind of reasoned through that they were the same, but we never really proved it. So what we could do is we could use, looking on the left-hand side here, we could use our sine identity and see if we can get it to match cosine. So this would be our sine identity with subtraction in the middle. So we'd get sine 90 cosine theta minus, and then they reverse, cosine 90 sine theta. Okay, and we're trying to get that to equal the right-hand side, which is cosine theta. Okay, so on the left side, we've got sine 90. Okay, you got to remember your values or think of your graph. Sine 90 is equal to 1, and cosine 90 is equal to 0, because remember, cosine starts high and then goes down to -1. So at 90 sine is 1, and at 90 cosine is 0. So we get 1 times cosine is cosine, and we get -0 times sine is 0.